MLOps is the new branch that has been created from the data ecosystem. The purpose of MLOps is simply to deploy ML models in production reliably, efficiently, and consistently. While it may be possible just to copy a Jupyter notebook into a Python script, save the notebook as a pickle file, and create a Flash endpoint for the frontend to use. But it sounds easy. Is it reliable, efficient, or even consistent? According to a survey conducted by Gartner, they found out that 36% of the data scientists would spend a quarter and a half of their time in deploying ML models. Even after that, also, 85% of ML models fail in the long term. This suggests that deploying machine learning models can be a time consuming and challenging process. And after that, also, many models do not deliver the expected results into production. Deploying ML models is hard, and maintaining them is even harder. So, what's the motivation for MLOps? If the part is still in the building phase, why should we pursue MLOps? But why MLOps? This is a very important question to ask. In YouTube or different mediums, you can find many videos on MLOps, what it is, how it works. But let's take a step back and understand why MLOps, why organizations should use it, or why you should look for it. Is it mature enough such that you can rely to create scalable solutions? Or would this be some part of the technology that will dissolve over time? First, let's start with the initial building blocks first. How MLOps originate? The year was 2009 and Facebook was doubling its users from 150 million to 350 million in a year. Twitter was also doubling its users from 2 to 4 million users in a year. And overall, tech industry was booming like no other at that time. iPhone 3 was released and it ensures many people should be connected on the internet more than ever. All of this is great, but how does the tech infra handle it? Well, quite simply, it didn't. There were both major and minor outages, DDoS attacks, cloud service down, scalability issues, rising server costs, and many more. During that time, just to provide a context, AWS was just 2 years old and GCP was just 1 year. And AWS was just offering S3 and EC2 service at that time. So cloud was also maturing. So in tech, most of the workplaces, they have front-end and back-end. Front-end developers are responsible for building and maintaining the client side of a web application. This includes writing code that runs in the user's web browser, creating and styling user interfaces, and implementing client-side logic and interactions. Backend developers are responsible for building and maintaining the server side of a web application. This includes writing server-side code, setting up and maintaining databases, and integrating them with other systems and APIs. For a basic organization, it is easy for backend and frontend to communicate with each other and create a service for thousands of users. But as the team grows, you need more collaboration, reliability, consistency, and efficiently in the services you provide. Services such as CI/CD, automation, deployment, caching, and many more. So, who would manage these services? Who would own it? Here comes the DevOps. They manage the operations for the developers. DevOps professionals are often responsible for implementing and managing these practices and tools, as well as helping to bridge the gap between development and operations teams. DevOps MLOps sound familiar? This is because what DevOps offers efficient reliability and consistently across developers, MLOps offers the same to data scientists. DevOps manages end-to-end lifecycle of software development. For managing end-to-end lifecycle of the data scientists, MLOps is created. The lifecycle of both software development and data scientists are mostly similar, but there is a very important difference. In data scientists, there have been many experimentations done to the project to understand which of the models is working for the models to be productionized. Where in software development, the rules are pretty straightforward and it's very understandable. The DevOps process is a framework for building, deploying, and operating software applications. The DevOps process consists of the following phases: plan, code, build, test, release, deploy, operate, and monitor. In the plan phase, the team creates a plan for the software application, including the features and functionality that will be included in the software development process and in the release schedule. In the code phase, the team writes the code for the software application using the programming languages, frameworks, and tools that are appropriate for the project. In the build phase, the team compiles the code and creates a build of the software application. This build includes all of the code, assets, and the dependency that are needed to run the application. In the test phase, the team tests the software application to ensure that it works as expected and that it meets requirements and specifications that were defined in the plan. In the release phase, the team creates a release of the software application, which is a version that is ready to be deployed to production. In the deploy phase, the team deploys the release to the software application to production, making it available to the customers. In the operate phase, the team monitors and maintains the software application in production, ensuring that it is stable and reliable and responding to any issues and incidents that may arise. In the monitor phase, the team collects and analyzes performance and the usage data from the software application and uses this data to improve the application and drive better business outcomes. Now, the MLOps lifecycle is similar to DevOps lifecycle but is specifically designed for machine learning models. Now, if you have understood the DevOps lifecycle, it's easy to adapt to the MLOps lifecycle. Here, first, instead of plan phase, there would be an EDA phase where the team explores the data that will be used to train the machine learning model and identifies any patterns, trends, or anomalies that may be relevant for the model. In the data preparation phase, The team creates the data for model training by cleaning, transforming, and augmenting the data as needed. In the model development phase, the team trains and evaluates the machine learning model using the prepared data and appropriate algorithms and techniques. In the model retraining phase, the team updates and retains the model as needed based on a new data or changes to the business requirements. In the model review phase, the team reviews the model and its performance and makes any necessary changes or improvements. In the model deployment phase, the team deploys the model to production, making it available for inference and prediction. In the model inference phase, the model is used to make predictions or recommendations based on real-time data. In the model monitoring phase, the team monitors the performance and accuracy of the model in production and uses this data to improve the model and drive better business outcomes. Overall, the MLOps lifecycle is similar to Devops lifecycle, but it is tailored to the specific needs and requirements of machine learning models. Therefore, Devops is not MLOps, but it can be similar, but still not entirely. Now that we have understood the importance of MLOps, let's understand what MLOps is and its challenges. MLOps stand for machine learning operations. To explain my analogy in definition, it is a set of practices that aims to deploy and maintain machine learning models in production reliably, efficiently, and consistently. To understand where your organization or expertise lies in MLOps, there is an illustrated view of understanding MLOps maturity models. The purpose of MLOps maturity model is to provide a framework for understanding and improving the processes and practices involved in managing machine learning projects in a production environment. The model shows the different stages of maturity that an organization can achieve in terms of its ability to create and operate a machine learning application environment, and can be used as a metric to measure the current state and progress of an organization's MLOps practices. To understand it in a clearer way, there is an analogy in terms of MLOps triangle. The MLOps triangle consists of no MLOps, Devops but no MLOps, automated training, automated model development, automated model deployment, full MLOps automated operations. We will go each step one by one. First, no MLOps. It describes a situation where managing the full life cycle of a machine learning model is difficult. The process of building and deploying models as well as testing them is manual. There is also no centralized tracking of model performance, and training models is also done manually. Devops but no MLOps. Here, releases are less painful than in the absence of MLOps, but they still rely on the data team for every model. However, the process of building models is automated, as is the testing of the application code. There is still a limited feedback on how well the model performs in production, and it is difficult to trace and reproduce the results. So in summary, while this scenario is an improvement over without MLOps, there are still challenges related to performance and traceability of machine learning models. Automated training. The training environment is fully manageable and traceable, making it easy to reproduce models. Releases are manual but have low friction. The process of training models is automated and there is centralized tracking of model training and performance. Still, it doesn't have ML specific features such as automated releases and A/B testing framework. Additionally, there is a system in place for managing models. In summary, this scenario is characterized by well-managed and traceable training environment, as well as automation and centralized tracking of model performance. Automated model deployment. Releases are low friction and automatic, and there is full traceability from deployment back to original data. The entire environment from training to testing and production is managed. Additionally, A/B testing of the model performance is integrated to the deployment process and all the code is automatically tested. There is also centralized tracking of model training performance. Still, it lacks new development in MLOps such as model registry and feature store. In summary, this scenario is characterized by well-managed environment with automation and traceability throughout the machine learning model lifecycle. Full MLOps automated operations. Scenario where full system is automated and is easily monitored. Production systems provide information on how to improve, and in some cases, they automatically improve with the new models. The process of training and testing models is automated, and there is verbose centralized tracking of metrics from deployed models. In summary, this scenario is characterized by a highly automated and well-monitored system with a focus on continuous improvement and uptime. Managing MLOps is still a very tedious job, and it comes with its own challenges. Some challenges which you haven't experienced before. As we have provided, if we remember it, we have pointed out previously, 85% of ML models fail in the long term. So why does it fail? What are the challenges that it faced to deploy the models? In a general way, there are three types of challenges that MLOps face: the organization, the operation, and the system. The organization challenges. MLOps engineer can be understandable, best described as a jack of all trades. They have their expertise lying in many domains, such as data science, data engineering, software engineering, Devops engineering, and backend engineers. It is a responsibility for an MLOps engineer to find a common set of goals and processes among all of these teams for smooth process flow of the projects. While there is some overlap between MLOps, ML and software projects, overlooking these differences is a costly mistake. System challenges. There would be an existing systems in place for your engineering team. It is the responsibility of your MLOps to respect the current infrastructure system and add or modify it such that they aren't creating a repetitive or parallel system, but enhancing the current architecture to reduce the maintenance and increase the time to deliver. This new system should be battle tested and should handle demands demands of training and deploying large, complex machine learning models, providing the necessary infrastructure and support for training and deploying machine learning models at scale. Operation challenges: creating SOPs for model deployment, productionization, experiment, and CI/CD. Creating a proper test cases such that no bugs or code goes into production. Proper backup strategy rollback in case of failures. These kind of operations are also needed in all of the ML models, so it can be highly configurable and maintained. Now we have came to the final thoughts. MLOps is a critical component of successful machine learning projects as it enables organizations to manage the full lifecycle and process of data science tools. The path for MLOps is still in the building phase, no doubt on that part. But still, that means that there is an opportunity for organizations to get ahead of the curve and establish a competitive advantage by implementing MLOps best practices and processes. By investing in MLOps now, organizations can position themselves to effectively manage and optimize their machine learning systems in the future and drive better business outcomes. There are many places where it can go wrong, but when it works, it makes the data team more collaborative, resilient, and models more reliable, consistent, and efficient. In the future, I will also touch upon the MLOps architecture and the components that drives the MLOps framework. As for now, I hope you understood why MLOps is there, why we are using it, and how you can use it on your architecture. Till then, see you on the other side. Thanks.